Right, I think it's 10:30, so I think we can make a start. So good morning, everybody. I'd like to thank everybody for attending today. Our Developing Innovative Fleet Management Solutions with HERE Location Services webinar, brought to you by our partners HERE Technologies. I'd like to thank our guest speakers today. We have Dieter Wallmann, who's a Senior Product Manager, and Alexander Osaki, also Product Manager at HERE Technologies. So we have great expertise today to talk about these fleet solution APIs. Just a couple of housekeeping tips. If you have any questions throughout today's presentation, just please pop them in the question pane and we'll get along to that towards the end of the call. There'll also be a live poll, and if you want to view the slides, we will send them to you after today's call. Just a quick look at our running order today and some of the things that we'll be covering as we work our way through the slides. So Grey Matter is a sales distributor for HERE Technologies, and we've been proudly working with them for around a decade now. We see HERE as being a very exciting innovator in the location services space, and we're very much looking forward to today's discussion around their sophisticated suite of fleet management APIs. And I would like now to hand over to our first speaker, Dieter Wallmann.
Thanks, Sean, for the introduction. I'm happy to guide you through our subject here, developing innovative fleet management solution with the HERE location services. Let's start with an overview where we think HERE location services can help you in fleet management. And what we see from our customers, from a lot of discussions, is one or the key information you need in all logistic use cases is the estimated time of arrival. You need to calculate them as precise as possible to meet your service level agreements, to improve your customer service. It's about meeting delivery time windows, avoiding penalties, and also the driver hour of service requirements. So this is the key help that we can provide. Then it's also about increasing the asset utilization by optimizing the routes, the route sequencing, having multiple waypoints and time windows in a route planned. It's about, of course, lowering the operational costs, finding the shortest routes, taking into account toll costs or finding alternatives if they are worth to be taken without toll cost, things like that. Of course, it's also about enhancing the driver experience to help them doing their job, which is mainly about providing them an integrated and reliable navigation system with voice guidance, turn-by-turn navigation, also taking into account, for example, truck attributes for heavy vehicles. I'm going to talk about this in a few minutes. And then last on the list, what we see is the improvement of safety, really understand driver behavior and have analytics on how to improve driver behavior to gain more security and safety. How do we deliver this value to you? This is our offering. Our HERE location services is a set of web APIs. They are all building up on what we call the real world index, which is our HERE map content, map data, not only road segments, all the address information, land use information, geometries, everything that you need to build a map and to work with location services on this map. And then you see here listed around the real world index all of the different services that we are offering. I will talk later about them, which are relevant for the use case we are discussing today in fleet management. And then to use these services, you can either go through our web APIs, the RESTful web services as the machine-to-machine interface, or our JavaScript APIs that also provides you some UI components that you can easily implement a browser-based application and integrate this with your UIs. And on the other end, we are also providing native APIs for Android and iOS that help you to develop native on these mobile and devices. When we talk about logistic use cases, we identified 3 key phases. And that's how my presentation goes. I would like to show you how we can help in each of these 3 key phases. The first one is about planning. In advance, you plan your routes, your trips, your deliveries. Then when the vehicles are on the road, you want to monitor them and you want to support the driver while he's on the move. And then when they are back from the tour, you want to analyze driver behavior, see if you can do anything to improve safety or any other things to optimize your processes. In the plan in advance phase, I listed here a number of services which I will go through that can help you here. And then later I'll go through some of them in more details. So start with custom locations. This is a service where you can upload and manage your own addresses, your own POIs, and pinpoint them into the map and can use them as destinations for pre-trip planning. To get them into the map, you can use the address information and run our forward geocoding that matches them with the location on the map and also can improve the address quality in terms of the road and address related informations of the address. Then we have as the most important capability, if we are talking about heavy truck route planning, our truck routing capabilities. And important to have truck routing in combination with traffic enabled routing, because having reliable traffic information is the most critical input for calculating a reliable estimated time of arrival. Then we also offer a toll calculation functionality for planning those toll costs along the route. And we have 2 other services that are very important in the pre-planning phase. First is the waypoint sequencing that is able to optimize the sequence of waypoints for a single vehicle. And then the tour planning API, where you can optimize routes for multiple vehicles. That's where my colleague Alexander will be talking about soon. Let's start with truck routing. For truck routing, we collected all the restrictions that are relevant for trucks that can be seen on the road, be it physical restrictions, just such as height and weight restrictions, as well as legal restrictions and all the hazmat good restrictions that are on the road. So you provide through the API interface the profile of your truck and then get a route calculated that is legally allowed and also physically allowed to be taken by the road. And in combination or based on the vehicle's weight that you provide, we also apply different speed profiles. You can imagine that a 38-ton truck runs a little bit slower than a 7.5-ton truck, for example, and therefore we also have different speed limits in the back end depending on the vehicle weight. This truck routing can be or should be combined with traffic-enabled routing. When we talk about traffic-enabled routing, we have 2 flavors of it. First of all, it's the real-time traffic data, which you also see when you're using your navigation system, and it gives you traffic information ahead, which works for the next 60 minutes of your trip. and it's permanently on a minute-based updated. But when you do pre-trip planning, it only helps you when your truck starts as of now. If you plan for longer than 60 minutes ahead, then we have traffic-enabled routing using historical traffic data. And this is what I think for the pre-trip planning more relevant than having real-time traffic, because this is the data that we created out of statistics from the real-time traffic speed information for the past year and permanently update this. So this gives you the indication that on a specific road on a Monday morning, even if you do not know the real-time situation, the traffic speed is lower than if you would drive the same road segment on a Sunday night. Yeah. So this helps a lot in pre-trip planning to have a better estimated time of arrival. And then I was also mentioning toll cost calculation, especially when you have a long transportation through Central Europe, crossing several country border. It's really a challenge if you want to go through all the different toll systems and calculate the applicable toll costs for each country, or sometimes even for each toll system within the country. And what we do with our toll cost calculation API, it's a one-stop shop where you can get the toll cost for a whole road starting in Lisbon and going to Scandinavia or wherever, taking into account all the different country and toll system specific rules, applying them based on the vehicle profile, and then providing the toll cost per collection system per country for the whole route. The next one on my list for the planning phase is the waypoint sequencing functionality. That's about solving the traveling salesman problem. So you have one vehicle, and for this vehicle up to 100 waypoints, and you want to have an optimized sequence, either having the shortest distance overall or the shortest driving time overall. We also have a mode where you can get the highest commercial value, where you can also pick up potential loads along the road, for a kind of sharing models. It consists of all the parameters what I was talking about, so vehicle type, truck attributes, your start time. It can also consider time windows at each waypoint, and it returns a list of those waypoints in an optimized sequence. So this is the traveling salesman. And when it comes to more complex problem, how we can solve this is something my colleague Alexander will explain.
Thank you. Yes, so when we're talking about tour planning, we're talking about solving the traveling salesman problem for multiple vehicles within a fleet. So this is route optimization for many vehicles. It's the same kind of thinking, right? You have traffic-aware routing. You want to find the ideal waypoint sequences. And what we've done through this is to add in the ability to define constraints. So the user can define constraints as part of the tour plan. So what are their job requirements? You know, does the job need to be carried out with a refrigerated vehicle? Well, that needs to be matched against a vehicle that has a refrigeration unit. When we're talking about vehicle profiles, do we need to route, for example, specifically along roads that can be driven by trucks, for example? And then once that tour has been calculated, once that's been sent out to the vehicles, how do we adapt to changing conditions? So changing traffic conditions, new orders coming in, things like that. So what we can do through the tour planning API is resubmit the tour basically, and then recompute it on the fly based on those new or changing conditions. So if you go to the next slide, Data, there's a little bit further explanation in terms of when we say optimization for multiple constraints. This is an area where, if you think about it, when we're trying to solve this traveling salesman problem across multiple vehicles, there are two components to that. One of them is understanding the best way to route between any 2 points. And then the other is taking that sequence of routes, that matrix of routes, and then figuring out the best order to run them in based on different constraints. So that's time windows, for example. It's when can the job be delivered? It's how much capacity is required for the job. It's are there particular driver skills required? And it's also, is it a pickup or delivery, or both in some cases, right? If you need to create a tour that is a mix of multiple types of jobs at one stop. So when you combine that information about the jobs and then the information about the drivers, so what the driver skills are, what the shift times are that needs to be planned for, what the break times are, all of that can be thrown into the tour planning API to get one coherent result out. And that's something that is a cost time optimized route based on the user-defined configuration of the vehicles in the fleet. Now, the easiest way to show that, honestly, is probably just to show it live. So what I'll do now is I will show you a demo of what tour planning looks like. So let me just go ahead and share my screen. I think it's screen 2. There we go. So this is so the thing to make clear, first of all, is that tour planning as an API doesn't really have an interface. It's a REST API. You send information to it, you just get the tours back. So this is a front end that we've built to show what that information looks like, to show what the routes that are generated look like and how they're generated. So what I have, so I'm working out of the Berlin office. So we have a set of 60 parcels. These are delivery jobs, and we can see information about them. So again, these could be pickups or deliveries, but what we'll do is based on the number of vehicles we have, we can see what the best sequence of stops are for each of these vehicles. Now, we're using 4 out of 10 vehicles in the fleet, and we can see what the tour length looks like, what the stop configuration looks like, and the fact that we can make all of these deliveries with only 4 vehicles. But if we change the parameters of that, for example, if I say I have a very narrow evening shift, and then I plan that again, then you can see that it takes 8 of the vehicles in order to handle all of these deliveries. So this is that case where, from a planning point of view, that means that we can see, we can optimize in advance. We can forecast better how many vehicles we will need, what the fleet utilization will look like, what we would expect the tours to look like in terms of time, in terms of cost, in terms of allocation across the different drivers, as well as not just that kind of operational side of planning, but also future forecasting, right? So we have, we're starting here from a depot in the city center, but what if we moved to the suburbs instead? In that case, we can see that if we have, again, that kind of narrow delivery shift, that narrow time window, then even using all of the vehicles in the fleet, we can't make all of the deliveries. Now, job priority can be part of the input data for the tour planning API. So of course, it's possible that you could say, well, these high priority jobs will be handled, and we will just kind of skip some of the others. Or we can say, well, what does it look like if we change the shift time, if we expand this to a full day? Again, we can do this with only 4 vehicles, like when we were located in the city center, but the time and the cost is different. So this is that area where, by being able to perform these calculations quickly and based on kind of real world information, we can allow for more effective and more accurate planning and forecasting to be done. So that's more or less as was said, that kind of extension of the waypoint sequencing into the full tour, where we're talking about solving it for many stops and many vehicles in one place, in one package. So with that, I will hand back over to you, Dieter. Thank you.
Thank you, Alexander. So that was the, as I think, quite impressive demo. Let's continue. We were in the planning phase. Now we are getting into monitor and support while the vehicles are on the move. And the first service that I listed here is about geofencing. So with geofencing, you can define areas, and then you can get from the service the automatic information if the vehicle is either entering the area, the defined polygon, or it's leaving, or where is it locating within or outside a certain polygon, and you get the distance to the next border. Then a nice service for any kind of dispatching and planning purposes is the Isoline routing service. Isoline routing gives you an area of reach for a certain vehicle within a certain driving time or distance. I'll talk about this later. And with this, you can, for example, identify vehicles that are in a certain area of reach around a destination. So show me all of my vehicles within an hour, all taxis around a pickup point within 10 minutes driving time, or whatever other use case you have. Matrix routing is an underlying service that we also use for our waypoint sequencing as well as for our tour optimization. So it's a service that provides a large table from a number of destinations to a number of destinations and could be used either for these sequencing optimization use cases, but it could also be used to in terms of a 1 to 10 or 15 matrix, where you just have one single destination and check out all the locations of the vehicles around this location, this single one, and then with one matrix request, you get for each vehicle the driving time and distance to this new pickup point. And this helps the dispatcher to easier decide whom to assign to a new job. Then we have estimated time of arrival tracking, which I will explain in details later. And we also offer a mobile SDK for developing turn-by-turn guidance information, as well as the Fleet Connectivity API for integrated navigation connecting the back end with the driver. Let's start with the first one, with geofencing. As I already explained, you can monitor your mobile assets in relation to a polygon, any kind of geographical area. You can search for the position in or the distance to the border of the polygon, and you can upload either your own polygons, just draw them or import them from a GIS software. You can also geofence against our map content, so against a certain postal code area or a district or whatever other polygon data we have in our database. Or what is also interesting, you can combine geofencing with our Isoline routing. This is our Isoline routing. As I said, it provides an area of reach from a point, or what we call reverse Isoline routing, to a point, and shows you the area that can be reached within a certain driving time or distance. And what is the exciting part about Isoline routing is it works with all of our routing, transport and vehicle modes. So it's supporting real-time traffic as well as historical traffic, which is relevant, especially when you are in a city and you have an Isoline from out the city. Either you do it in the morning or in the afternoon, depending on the rush hour traffic, the Isoline can look significantly different. So that's a really interesting aspect. As well as you combine it with truck routing, then this considers the specific speed profiles for heavy trucks. So the more weight you have for a truck, the smaller the Isoline is, that the area that the truck can reach in a certain driving time. And we as well also support car and as well as pedestrian route calculation for Isoline. So this is a really lot of use cases behind Isoline, also outside also of logistics, also for marketing, areas of reach around a store. So how many customers are within 2 hours driving time to my store? This is another interesting use case that you can solve here with Isoline routing. And what I wanted to introduce as another use case in combination with geofencing is when you want to have a notification prior to arriving at your loading destination or delivery destination, then you can create an isoline of, let's say, 10 minutes driving time around your destination. And as soon as the vehicle then enters this destination, so this is how this could look like in combination geofencing, you create an alert or a notification that the people at the loading dock know now this vehicle is within 10 minutes reach to your loading dock, and you can start preparing everything. So this would be a combination of Isoline routing and loading this then up as a geofence to the geofencing service. Then I already talked about matrix routing or also large-scale matrix routing. So matrix routing is able to calculate matrices up to the size of 10,000 to 10,000 destinations. This is really high performant. And it supports as well all the modes, be it traffic, truck, pedestrian, shortest, fastest route. And as I said, it can be used, and we use it as an input for tour optimization or waypoint sequencing, but can also be used with smaller matrices for the dispatching use case, 1 destinations, 50 vehicles, and for each of them, you know, with 1 request, driving time and driving distance. Yeah, and then ETA Tracking. This is a special tracking application for long distance transportation. What we see as of today, a lot of our customers are doing, they use our reverse geocoding service and in combination with our routing service or only our routing service, take the actual position of a vehicle, send this to our routing service and calculate the remaining driving time to the destination. This is already fine and helps a lot. But what if you only send your latest coordinate to the service doesn't know any history of the route. It does not know if the driver already reached at his previously planned stops. It does not know if he has taken all his rest times and other stops which are needed. And this is what ETA Tracking does. Instead of sending only the actual position, you always send the service the complete GPS trace out up to that point where the vehicle is currently. And then the service extracts out of this information the taken stops. So if you see the 2 pictures on the left side, the first one is the pre-trip planning, which indicating the short and the longer rest times along the route from Frankfurt to Setúbal or somewhere in Portugal. And the second screen, the blue line shows you the historical trace up to that point where the vehicle is now. And being able to take the taken rest times and the still open rest times into account, you have a much more reliable estimated time of arrival. If there is a 1 hour stop due, and even if you don't only have half an hour to your final destination, but before that you still have to do this 1 hour stop, that might make a big difference in the final arrival time. And that's what we try to cover here with the ETA Tracking functionality. Then our Mobile SDK, available for Android and iOS, and it's supporting the full truck routing functionality with all the legal and physical restrictions as I introduced earlier, as well as hazard goods, and of course also supporting the truck-specific speed profiles. And with that, you can develop a truck navigation application that you can also integrate with your other mobile applications for the driver, where you then have full voice guidance with all the truck attributes that can also be displayed in the map in case the driver wants to see them. We have spoken speed names there. The vehicle position is map matched, and you have the full guidance information, also including what we call natural guidance, where you have spoken POI information at the petrol station. You have to do a left turn. Also including lane assistance and of course support of real-time traffic, because then you are on the road or the driver is on the road, and that's where the real-time traffic information is most relevant for the driver. The here Mobile SDK together with our lead connectivity API can then be used to do a real what we call integrated navigation. So the fleet connectivity API allows the dispatcher to send destinations directly into the navigation device. The driver sees this in his inbox and accept them, and the route calculation and guidance is started. So no need to call the driver, give him verbally a new address or send him a text message, and then he has to re-enter the address. It's directly getting into his system, he accepts it. And when the route calculation is done, the calculated arrival time on the device is then automatically sent back to the dispatcher, so that he has the confirmation by when the arrival is supposed to happen. And when there is traffic on the road, a delay on the road, you can also define a certain threshold. And then if it's over this one, an automatic update is also generated from the mobile device. So deep integration between backend and the mobile devices in the vehicles. Okay, and then let's get to the third phase, which is the analysis. So the vehicles are back, and you take the GPS trace and can use it with our route matching service, first of all, to compute the most probable route. So then you can just simply double check if the vehicle was on the same route as originally planned. But it can also help to have a driver behavior analysis and detect illegal maneuvers for the driver. So to train him, to make sure to improve safety. For this, we have a lot of data available that can help for the driver behavior analysis or really safety scoring analysis. And of course, toll cost also in the post-trip analysis can help. You can validate against incoming toll receipts, or you have immediately when the vehicle is back, you can calculate the applicable toll costs and have it for further processing. The route matching service is a service that was originally developed for insurance companies for the UBI, usage-based insurance, or pay-as-you-drive, how it's called, use cases, where you want to analyze driver behavior and calculate his insurance fee based on that one. The input is the historical GPS trace, where the service does a map matching of this GPS trace to our road network, assuming first of all the legal use of the public road network. Also considering typical inaccuracies of GPS traces. So what you see here on the screen, the black ones are really the GPS points as they come in from the device, and the green ones are then the matched ones, map matched ones to our road network. And with this information, the service can also detect illegal maneuvers. For example, here, when you were driving a one-way road in the wrong direction, first we assume it was legal, but at some point when there is no other possible match, it detects the information and gives you the output. This is illegal maneuver, one-way road in wrong direction, sorry. Or maybe you did a left turn where a left turn was not allowed, or you entered a restricted area. These are examples what could come back as illegal maneuvers. We recently also launched the detection of when you ignored a stop sign. This is also coming could come now as a response from the service. And then for further analysis, you can combine this with our map data that coming from the advanced here data set, where we have, first of all, speed limit information, where you can then detect overspeeding of your driver. But there are a lot of other information, like, for example, slope and height, that can you help to better analyze the fuel consumption. Also street type information, not only the speed limits, but also the traffic speed, how it was on the road at that time. So you can understand if your driver was running with traffic speed or significantly faster than the traffic speed around. Traffic signs and road geometry is also an interesting information. For example, you have sharp curves where are no speed limits, but based on the road geometry and the speed, you can analyze if this was a really risky drive or not. So a lot of map content-based information in combination with the route matching that can be used for post-trip analyze to do driver scoring and improve safety by training drivers on better behavior on the road. So yeah, let's summarize how we think we can deliver you value for connected trucks. I think we have a lot of capabilities, our high quality map content, which is used all over in the automotive space, in combination with our real-time traffic as well as our historical traffic, and especially for large vehicle, all the truck attributes that we have in our database for truck routing. We have what we call enterprise-grade products. We have a worldwide cloud service available. On worldwide means in all regions of the world, we have deployed them in Amazon data centers. The global scale and also the reliability, you're always, wherever in the world you use our service, you are connected to the closest data center, and we care for having all our SLAs and the availability of the service always in place. Yeah, as I introduced, we have different APIs to use. The functionality is independent about what kind of API you are using. And just to mention it, we also, I think more than 90% of our customers use our cloud service. This is our standard offering. But from time to time, we have customers who say, we do not want to use your cloud service. We want to run the whole software, the whole service behind our own firewall. Just to mention this, we also have a self-hosting option available. Then you download the software and install the software on your own servers and use our services completely offline, except you want to have information like real-time traffic that you can add on top of that. So this is the self-hosting option, only used by a smaller number of our customers, but still an important part of our location services business. Yeah, then this is something you have to discuss with our partners. I think we have very flexible license models, really designed or based on the business value that you create with using our services. So there's a different price point, of course, for navigation than just for tracking assets, for example. And we have a strong technical and customer support, and as well through our partners. We are more than happy to support you. Yeah, I think or hope this was helpful for you. We think with our location services, we have a strong offering as of today, and here as a company is doing a lot still in the automotive business, where the future is about highly automated and autonomous driving, where we spend a lot of investment in having even more precise road geometry and road information that enables autonomous driving. And this as well will help also our location services customers having even more precise map content information as underlying data for our services. Yeah, and with that, I'll hand over to Delphine for the poll, right?
Yes, thank you, Dieter. So it's time for our poll. Question is, which of the new functionalities that have been discussed are the most appealing to your company? So is it calculate a better ETA, increase the asset utilization, lower the operational costs, or improve the safety, or all of the above? So could you please vote? So 50% of the audience has voted so far. So let's wait some more minutes or seconds. While we are waiting for you to vote, let me remind you that we have a question window where you can ask all your questions. We saw that we have some already, but please feel free to ask more. So people are still voting. Okay, thank you. Then let me close the poll and share the results with you. So we have 23% interested in better ETA, 27% interested in the asset utilization, 8% to lower their operational costs, and 42% are interested in all the new functionalities presented by us. So with that, I hand it over to you, Dieter, or you, Sean.
Yeah, I think it's for Sean.
Thank you. Yeah, so I can
let's
see
get-
the questions have been blowing up. So we'll attempt to get through them all. So, do you open up your calculations of historical journey durations? Yeah, this is about the historical traffic.
Yes, yeah. So when you do the route matching and you see for each road segment exactly what driving time was spent and what speed was used. The speed anyhow comes from the GPS, but what we can share as information is what was the traffic speed that we delivered for the road calculation back in time, as well as the historical traffic speed. So we all expose this information. Yeah. It's also part, if you do a routing request, you also get exactly the traffic speed based on real time and what would be the traffic speed based on historical traffic. Yeah, we expose that, yes.
Fantastic. So I hope that's covered that requirement. Another question about the historical data. Does the historical data take into account public holidays or large events such as sporting and concerts that might be taking place at that time?
No, that's not included because it's not historical data means it's not May 15 or May 16, 2018. Historical data means it's a typically Monday morning, 9 o'clock or a typical Sunday night. Yeah.
So I hope that, again, that's answered the question. So we're just going to move on. There was a question about the slides. Yes, we will be sending the slide deck at the end of the call. So moving on to this one, you've mentioned the customization of routing constraints during the planning. Could you please articulate how one defines a custom constraint with the tour planning API?
I think that's for Alexander. Yeah, so the way that that's handled is that as part of the when you define the list of jobs, so you would define that as a JSON file or something like that. You define characteristics for the jobs and characteristics for the drivers or the drivers of the vehicles, and then those are matched in terms of the sequence. In terms of the route itself, then there are a couple of ways to approach that. The easiest is to just break it down by whether we're looking at cost or time. You can also, like for example, we also have APIs that cover CO2, say, if that was something that you wanted to optimize against. But then also the whether or not you're routing with trucks or with you know, with like commercial vehicles or cars. So those have slightly different behaviors in terms of which roads are open to them, in terms of how we handle the way that they're routed. So if there are specific requirements or restrictions, areas that they're not allowed to go, then that factors in. But fundamentally, the tour planning side of it is kind of stacking up the user constraints in terms of time windows and priorities. And, you know, I need this job to be served by this particular driver because they have the you know, the access card to this campus or something like that, and then feeding that into the API.
Thank you. We've got another question about the tour planning. If you're planning vehicles for large fleets with more than 200 vehicles, how would you suggest we structure the planning grouping?
I mean, that's within the capabilities of the API. I don't think so. I don't really know, to be honest, that I would do anything special about that. It can be instructive, I guess, to if you have them assigned to different depots, or if there are different starting locations. That's also, I think, possibly a constraint. But in general, yeah, that's not a requirement.
Perfect, very good. We have a question asking if the Mobile SDK is available for use in Xamarin Forms yet.
No, it isn't.
We can take a look at that. There's also the Flutter SDK as well, but we can we'll
exactly. That's a good point. That's what
directly talk about that one.
Yeah.
Very good. So yeah, loads of questions coming in. So do you have or plan to have any support for retrieving current speed limits from variable speed limit zones, such as smart motorways?
Yeah. So in real time, we do not have it yet. What we currently launched are in the post-trip analysis, what we call variable speed limits. So speed limits depending on a specific time of the day, or based on for specific weather conditions. So we are also looking into that one, but not the dynamic speed limits online yet. No.
Another question, how many vehicles and stops are supported in the tour optimizer?
You know, I don't know offhand. I'll have to get back to you if we can do that.
Fantastic. Yeah, we'll pick that up offline after the call. As an example, how one can define balancing of route duration across groups of vehicles representing different logistics providers. Another example, how we can define depot throughput limits. So yeah, it sounds like it's two parts to that one.
Yeah, and I'm sorry. Can you read the question again? Because I'm not entirely sure I followed it.
Yeah, I'll just read the first part. How can we define balancing of route duration across groups of vehicles representing different logistic providers?
I think what you would do in that case is you would either have separate job profiles. You would have separate jobs for the different providers, or you would define that as part of the vehicle configuration. Like you would list the provider, or you would associate the logistics provider to the vehicle.
Yeah, so there's lots of different parameters they can use. The second part of the question, I think, is how they can define depot throughput limits.
I mean, so capacity is part of the tour planning calculation. So if you and that's a dimensionless quantity. So if you need to factor that in, you can define sort of you can kind of define the capacity limit against the vehicles, for example, which I think would be probably inherited by effectively inherited by the depot, just based on the way the API parcels out jobs.
Fantastic. So yeah, lots of questions coming in, Alex, about the tour planner. So we have another one. It's very similar to the previous question. What is the maximum number of drops/jobs that the tour API can realistically cope with in one request?
So again, the exact numbers have are increasing, so we need to follow up with that later. But there's a couple of different ways, like there is a couple of different approaches to this, because one of them is that sort of on-demand case where you're looking at very narrow delivery time windows in the very near future, in which case you're probably adapting for, you know, maybe only a handful of stops because the driver is going to come right back and then head out again. And the next is where you're looking at something that would have, you know, a day's worth, a whole shift's worth of jobs. So the use cases for those are a little bit different because it affects how much time is required to do the calculations, and it kind of affects how you expect to be using the tour planning API. But it's not really the limit in that sense, kind of air quotes around that, is not around the number of jobs. It's around whether it's important to prioritize for the speed of the tour calculation, or whether you are, you know, planning something the next day or the next shift, and yeah, being able to scale up to larger job sizes is valuable.
Fantastic. Hopefully that's answered that one. We've had a request for some technical support information. We'll follow up with you separately. If we have more, another question about the planner. If we have more than 120 points to visit by our set of vehicles for which we need to get routing plan with some constraints, is that case how we can use here route plan service?
Yeah, so it would not be the route plan, it would be the waypoint sequencing functionality. So we tested it with up to 200 waypoints as well. I think we have in the moment a physical limit at 150, but we could, in a customer case, raise this on request to up to 200. I think that's what we already tested. It's very much depending how long your routes are. If it's over whole UK with 200 waypoints, it might be a problem. It's only in a single city with 200 waypoints and shorter distances, significantly shorter, it should work. Yeah.
Fantastic. More general question. Do you have cheapest route option, which will consider the toll costs versus the fuel costs?
Yes, we have that. It's not directly against the fuel cost. It's toll cost in versus the cost per distance and per time, so mainly driver cost. That's where we have it. The interesting fact out of this, we did a lot of tests. At the end of the day, in most of the cases, you should stay on the toll road. That's the outcome.
Fantastic. We've had some requests about the examples. We will share with you the developer.here.com links where you can get a lot of this documentation. We've got a question about the matrix routing. How fast is the matrix routing calculation? For example, with 1,000 delivery locations, what typical time would it take to produce a result, please?
Yeah, again, same story. It's very much depending on the distance of the single routes and also on the road, on the mode. But we are talking about a few minutes. So 1,000 by 1,000 matrix, I think we are in the time of, I don't know, 3 to 5, 6 minutes. That's the dimension we're talking about.
Fantastic. So an existing customer is asking a question about storing routes. So we already use your API to create routes for coaches using truck routing. Can we store that route created using a unique reference and send that to the mobile application for the driver to accept, rather than the route being recreated each time by sending the waypoints again?
This is more of a legal question. So in general, you are allowed to cache our result for up to 30 days. And as I understand the use case, I would simply say yes, yeah, but no legal review.
Thank you very much. We've had a request for documentation and examples for route matching. Again, we'll come back to you. We'll share with you where all the demos are, so you can get to that resource. So that's that one. So we're just having a look. we've got a question. How do we handle privacy with drivers' data? So meaning driver behavior.
Yeah, that's a good point. As I said, especially the route matching and post-trip analysis is used for a lot of insurance companies. At the end of the day, it's our customer who has to comply with all the privacy requirements. For us, each GPS trace or each coordinate is completely anonymous. The only thing that we know it's coming through, that we can identify, is the app ID, that it comes from a certain business customer from here. But that's it. We do not have any further information about which individual is behind this GPS trace.
It's fantastic to know. Another question about the SDK. Is anything available for native script? And is there any plan to provide this in future?
Not that I'm aware. For the plan in future, we have to come back. I have to check with the PM for our mobile SDK.
Fabulous. I think we've got time for a few more. There's more questions coming in. So I think this has been asked before, but I will mention it. What are the runtime limits of the tour planning API? Maximum stops, maximum vehicles, and what would be the optimization time for 100 vehicles?
So, I mean, again, broadly speaking, the optimization time for 100 vehicles is going to depend a lot on what other constraints are part of that, in terms of whether, like, what the shift time looks like, how long the jobs take, how much priority is being factored into it. So it's a little hard to answer because it depends. You saw in the demo that the calculations for what things look like when we're talking about 50 jobs or 100 jobs, and like obviously it does take longer when you have more complex routes, but a lot of that depends on the complexity that is required by you in terms of making those calculations. So it's highly variable.
Fantastic. Yeah, we can discuss any individual customer use cases in more detail later. So another question about the tour planner. Can the tour plan balance all of the waypoints across multiple vehicles and optimize to achieve similar route durations for all vehicles rather than the lowest number of vehicles?
I'm pretty sure. So again, I will double check this. I'm pretty sure the answer is yes, because that's one of the, when you're considering whether you're balancing against time or cost, for example. If you're balancing for time, then that's something where you may need to change the way that you're calculating things so that you are using more vehicles, which you see when the shift time is condensed. So in general, we will return the lowest cost route, but I think it's possible to change the parameters to get different results back.
Fantastic. So yeah, again, another tour planning API question. Does tour planning support a final destination for the truck? So a home return plan. This is so we can continue and queue tours.
Yes. So, and this is something that, for example, that we've implemented, whether you're talking about like return to depot versus the driver doesn't have, like whether you're talking about like a closed loop tour or not.
Fantastic. So question about the matrix API. If we need distance and duration matrices for different times of the day representing traffic slices, are such matrices built individually?
Yes, each of them is built individually. Each is one, you send the same matrix with different start times, and then the different traffic patterns at that time of the day got applied.
Yeah, again, as that's a licensing question, is worth us following up after the call just to discuss that in more detail, how they're using that API and which plan will be needed. Another question, how would I link my vehicle telematics solution to the HERE solution to provide real-time vehicle data to be compared against the tool results returned by HERE?
Yeah, so the implementation has to be done on the customer side. So what you need to do is you do our pre-trip planning. So use our routing service, store that as that routing request with the travel times. And then when you're done with the route, you upload the GPS trace. And then our route matching service more or less has the same syntax and also the same response structure as you do a routing request. At the end, it's also a route request, but with more waypoints in it. And then you can directly compare the pre-calculated driving times to the actual ones. But this is not something we offer. This is something then you have to compare one response to the other, but both are in the same structure. You can first of all check if it was the same geometry as originally planned, and if it's that, then you can compare road segment by road segment and driving time on that.
Fantastic. Yeah, it's all very modular, so it's interesting how you can snap all the bits together to get the results you need. So apologies if we haven't covered all the questions. We will come back to you and chat to you in more detail after the course. So I think we're out of time. So I'd just like to thank Peter and Alexander for their time and the very interesting presentations, particularly how you can use the APIs to solve one-to-many and many-to-many vehicle routing problems. I know that's on a lot of our customers' minds, and I really look forward to discussing with our customers how they're going to implement some of these features into their solutions. So fantastic. So as a final point, if you've got any questions about anything you've seen today and would like to discuss your customer applications, if you could move on to the grey matter here, contact information, if you could just reach out to us using the contact details on the slide. And thank you very much again, everybody, for attending the webinar, and enjoy the rest of your day.
Goodbye.